Okay. So we'll see the official uh, quick start tutorial of Numpy. And for those of you who like don't know, see, for those of you who know Numpy, this is going to be very basic. So you should please bear with this. But it is very important to understand the at least the simple syntax of NumPy for those of you who don't know about it. And okay, so you know about lists in Python, right?
Yes, sir.
And
Yes, sir.
okay, see, NumPy. So just like lists, so list is a particular data types, list and tuples. Whereas NumPy, if you want to perform mathematical operations, then like the best possible option we have in Python is NumPy. So NumPy's array class is called ND array. That's the data type, and or it's also known by this by the name array. And so you can check the dimension number of axes by using ndarray.ndim. You can check the shape of so this will give you the number of axes. So if it is if it's this kind of an array, matrix which is what 2 by 3, so this will give you 2. So the number of dimensions is 2. The shape of the array, okay, so this will be for matrix with n rows and m columns, so shape will be n comma m. This will return a tuple. And then there is this the size and ndarray dot size. So this is total number of elements in the array. So equal to the product of elements in the shape. So n into m. So this matrix, the size will be 2 comma 3. The shape will be 2 comma 3. The size will be 6. You can also do a dot d type. So this will return you what type of what data type uh, that that particular array belongs to. So NumPy has its own data types. NumPy.int32, NumPy.int16. So this is a 16 point integer, 16 point float, and NumPy.float64. These are some examples. And yeah, these are some things. So if you they also said it has NumPy ndarray.item size, so which is the size of in bytes of each element of the array. For example, an array of element type float has item size 8. Okay, so while one type of complex 32 has item size of 4. Yeah, so we can see an example. So to import NumPy, you would say like import NumPy as you can say anything, but this is the most common syntax. And then if you want to, okay, we will do one thing. We will run this so that it's much more clear. Okay, so let's say you first have to import NumPy as NP, and then so so what does np.arrange do? If you remember, I was using this in one of the class. So you see what this does is it creates a 1D. So you can create even a 2D array, but this creates a 1D array of numbers which are equal to total number is 15, and which starts from 0 and up to 14. So you can see what is the shape of a. So it says 15. What is the size of a? that is also 15. Now the next thing is, okay, so you can also do a dot reshape. So you can reshape this into a two-dimensional two-dimensional array. Okay, so now if you see this, so it becomes 3 by 5 numpy array. Okay, so the reshape function basically reshapes the whatever the input array into the dimension that you will provide. So you can, we have seen a dot shape, you can see a dot end dim. Okay, so this is 2 because you have 2 axes. And then, okay, so what is the data type? So you can say a dot d type, that will give you that will return you something which is of the type d type. But if you want to find out what is the name of that data type, so that is in int64. And okay, so this is about it. Now to create a numpy array, like from the data that you know, for example, you have these three values. So you are creating a numpy array from a list, you can see. So now A is an array, okay, which
Sir,
is,
reshape is changing array to in the matrix form.
yeah, reshape is changing, yeah, this 1D array into a 2D array, this one,
Okay,
okay,
sir. Okay, thanks.
yeah. Like for example, you can say here a equal to np dot array 2 3 4 5. Okay, so now this has
Yes.
got 4 elements, so you can reshape it as 2 comma 2. Okay,
But sir, what is the use of this in data science? Like means reshape function.
this is not a data science class now, this is a data analysis class. So so
Okay.
if you see, you will need it. I mean, when you do a lot of data analysis, you will see when you will need to reshape your arrays, and that is required. Okay, so
Okay.
do more and more of data analysis, and you will realize why is it required. Okay,
Okay, sir.
so then, yeah, so then you can also create a numpy array with float elements. So you can see here we create from a list which contains three float elements. So what is the output? So B has 1.2, 3.5, 5.1. And so okay, so numpy, if you give a equal to np dot array, if you just directly give this 1 2 3 4, this will give you an error. So it will give you a type error. You have to give it as a list. Okay, so you can, that's what, so you can give it as a list, and within that you can give two tuples or three tuples. So that will decide your number of rows in the array. So you can see now in B we have two rows, 1.5, 2.3, and this one. You can add another row to this one. Okay, so we added another one, but this entire thing, it goes in the list. Okay, so then you can also have this data type complex. So if you are working with complex numbers, so you can see this now. The array that it returns is having a real part and an imaginary part. So 1 plus iota 0, 2 plus is say 0, but iota is also used. And then there are these functions of numpy. So one is np dot zeros. So in np dot zeros, what it does is it creates an array of the size. whatever size you provide, but you see you have to give two brackets. Okay, this is very important. If you don't do this, it will throw up an error. So you see, if you do this, it
Sir,
it, it just throws it. Yeah,
sir, in the
yeah.
data types that int 64, 32, what is the basic difference between them?
So you know about like how much like so that is basically if you're not you're not read or gone through data types in Python class. So that is like int 32 basically means that you have in the memory, so you have a total size of 32 places. Okay. So because in the memory, your any number will get saved as binary, right? Because
Yes, sir.
it's our machines are still classical machines, right? They are not quantum computers. So they will get saved as binary numbers. So let's say, for example, I say 64 to binary. Okay. So, so this will be, I think, what is the binary number for 64? So this is the binary number for 64, right? So now this is having how many digits? 1, 2, 3, 4, 5, 6, 7. Okay. So now you add zeros, you prefix zeros to it so that the total length becomes 32. Okay. So this total length should become 32. Now if you have a 32 bit, so each of this is called a bit, right? So if you have 32 places, like that is, and if your data type is integer, so that is int 32. Now if you want 64, sorry, should, okay, so your total length of the number, the maximum length that you can save is uh, it can come in 64 digits. You understand what I'm saying?
Yes, sir. Sir, will it
Hmm.
affect the results when we does the computation? Uh,
It slightly affects the results, but not much. But see, but you should be aware of it. So that's what the Lorentz whole chaos theory is about. So you do you know about it? Have you seen this butterfly curve in any of your class on NWP or dynamics of atmosphere and oceans? So Lawrence was doing this experiment. He was running these. He had these three very simplistic equations. Okay, and so you know the values of sigma, rho, and beta, and then you just give the inputs of you just start with some initial conditions. Start with some x, y, z. So let's say when you start from 0, 0, 0, so you will keep getting the values of at the next time step, because this is an integral in time, dx by dt, dy by dt, dz by dt. So you will keep getting the value at the next time step. Okay, so this is the Lorentz curve. Okay, so then he got this kind of nice butterfly curve. But what he did was, so I mean, that's the thing. So he ran a model, like he ran these equations one day, and the next day, so he was also saving the data, and the next day, so he started another experiment, but at like maybe time step equal to 10, which he took as initial condition. And then, like, after some time, what he found out was that the resulting states of the system, that is what your x, y, and z are, they were completely different. Why that was happening was because when the system was saving the data, it was truncating some of these numbers. So it makes a difference, and so that is why we need ensembles in weather or climate modeling. So makes a difference, but not if you are doing some simple data analysis. Okay.
okay, sir. Whenever we call this array, right?
Hmm.
So we say that the machine is means giving that data types. It is somewhere it is giving as int 10, int 32, int 64.
Yeah, yeah.
So machine allocates it randomly, right? Uh, it
See, Python
is it
in languages like so in languages like Fortran and C, you need to explicitly mention about the data type. Okay, you need to define the data type first, and so you need to define the data type, and you in even in C++, but not in Python. See, Python on its own tries to identify the data type until unless you tell about it. So for example, in this one, so np.ones is similar to np.zeros, okay, but it will create an array of which will have all the elements as ones. Now this is of the size 2 by 3 by 4. If you provide the data type, it will understand. Otherwise, it will you are explicitly forcing, but otherwise, it's like it will assume based upon the values that you give. And in this one, it knows, so it's defined in this ones function. So what has to be provided? But otherwise, if you give something like this, if you are making an array like this, so it will so this you are passing float numbers, right? So it will assign float data type to this entire array.
yes,
Okay.
yes, sir.
So then you can also have this you have this np.empty. So what np.empty does is it will create an it should create an empty data type data set. Empty array, man. Why is it creating these numbers? I don't know what's the problem. But you see, it should ideally create an empty data array. So here you can see it's created some numbers like 3 into 10 to the minus 262, which are 0. So I think it is randomly creating those kind of numbers. And then you have np.arrange. So if so, typically we saw in np.arrange, if you just give a single number, it creates a series of or a vector or a 1D array which starts from 0 and total number of numbers is equal to, for example, here it is 15. But you can also do something like this. You can give where to start, where to end, and what is the step size. Okay, so this one gives you, so also the last one is never considered. So like if so in Python, if the last number is something that you are mentioning, or like it's, so it won't be considered. So here you see we didn't get 30, but if you say 10 to 31 comma 5, now you say it takes 30 as well. So that's np.arrange. You can also do, yeah, it also accepts float arguments. So you see from 0 to 2 with a step size of 0.3. Now you see it has not, yeah, so the next one will be 2.1. So now if you give 2.2, it will take 2.1. But if you give 2.1, it won't take 2.1. Oh, it's taking 2.1. How come? Maybe because it's float. Okay, ideally it should not. Also, Numpy has got predefined the number pi, and then just like np.arrange, there is something known as np.linspace. So what np.linspace does is it will create the numbers from 0 to 2, but it will create a total number of, so it will create an array with a total size of 9. Okay, so you see here it has created an array of size 9, 1 2 3 4 5 6 7 8 9. Okay, you can say 10, it will create an array of size 10. You can say 100. Okay, so that's np.linspace. And so you can also say np dot x equal to np dot linspace 0 to 2 pi, and then you divide all of them into 100, and then you can compute f equal to np dot sin x. Okay, so np dot, okay, so it says pi is not defined, so we can just take pi from numpy. We can say np dot pi. It defines that, and then say f equal to sin of x. Okay, so what is f now? F is sine of theta, where, or sine of x, where x is going from 0 to 2 pi. So you can print your arrays. So it's just the simple print statement. And okay, yeah, this is printing arrays. And then there are some basic operations that you can do on arrays. So arithmetic operations, they're saying, are applied element wise, and new arrays created and filled with the result. So if you have an array A which has the elements 20, 30, 40, 50, and if you have this element B which you are creating as np.arrange 4, so this will create 1D array with elements as 0, 1, 2, 3, and then you can compute c equal to a minus b. Okay, so c equal to a minus b will be 20 minus 0, 30 minus 1, 40 minus 2, 50 minus 3. So that will be 20, 29, 38, and 47. You can also do, yeah, different things like, you numpy has this sine function, it has got the cos function, and then you can just say, you can create a boolean array. So you can, if you say a, which is this one, is less than 35, so it will create a boolean array. Okay, so 20 and 30 are less than 25, so this is true. 40 and 50 are not, so that is false. Okay, now you have, if you have this array A, which is a 2D array, okay, of size 2 by 2, and B is also a 2D array of size 2 by 2, the elements you can see. If you want to do element wise product, okay, so then you would say, so element wise product, but we mean, so what we mean is, so 1 into 2, so this one multiplied with this 2, this one multiplied with this 0, so you can see 2, 0, this 0 multiplied with the 3, so 0, and 1 multiplied with 4, so that gives you 4. So that gives you an element wise product. But you, so there is a matrix product also, so that is basically first row gets multiplied to the first column. So 1 into 2 plus 1 into 3 gives you 5. Okay, then second row gets multiplied to the first column. So 0 into 2 plus 1 into 3 gives you 3. So similarly, you multiply with the second column, the first row and the second row. So for matrix product, you use at the rate. Okay, you can also do a dot. So numpy has got this function you have to say dot dot, and then b. Also there is another thing I'll show you. So this is your a, this is your b. So a into b gives you an element wise product. A at the rate b gives you a matrix multiplication. A dot b also gives you a matrix multiplication, and np dot a comma b also gives you a matrix multiplication. So you can see, you can do a element wise multiplication, a matrix multiplication. So then some operations, such as plus, equal to, and into, equal to, act in place to modify an existing array rather than create a new one. So if you say a into equal to 3. So this is basically what this basically means is a equal to a into 3. You can, the short form is a into equal to 3. So you can see that here array a, which was, where did we create a? So which was 2 3 4 5, now becomes 6 9 12 15. Okay, so it just changes your original array. You can also do a plus equal to. However, plus equal to, I mean, you cannot, I mean, you cannot do typecasting. Typecasting basically means that you cannot change the data type. So A is having a data type of integer, and B is having a data type of, let us say, what is B? So yeah, B is having a data type of floats. Okay, so it doesn't work like that. Then there is this RG. Okay, so you can also create random numbers. So NumPy has got this dot tuple object cannot be interpreted as. Okay, so to create a random number in NumPy, so it will generate some random numbers. You have to say np.random dot rand n, and then you have to give the size of your array. So you can give a 2D array, you can give a 1D array. So this just creates a random number. Okay. So then you can use the functions like dot sum, dot min, dot max. Okay. So let us say we are having a 2D array. So you say if you do a dot min and a dot max. So this a dot min gives you the minimum, and then a dot max gives you the maximum. A dot sum gives you the sum of all the numbers. And then you have, so how would you slice elements in a NumPy array? So for example, you have a is equal to np dot arrange 10 star star 3. So star star basically means raised to the power. Okay. So now if you see what is there in a, it is 0 1 8 27. So numbers, this generates numbers from 0 to 9, and then this what this does is it raises them to the power 3. Okay, so what are we doing? So we are indexing them. So the indexing basically starts from 0. Okay, so you see the element number 0 is 0, element number 1 is 1, element number 2 is 8. So this is actually the first element, this is the second element, and this is the third element. So but the indexing which starts from 0. You can also select multiple elements, so you can say 2 to 5. So in this one, last one is not considered. So 2 3 and 4 only are extracted, like the way it works in Python. So 0 1 2, so this is element number 2, this is element number 3, this is element number 4. So if you do 2 colon 5, 2 3 and 4 will get selected. If you do 2 colon 6, 2 3 4 5 will element number 2 3 4 and 5 will get selected. Okay, so then you have so you must have seen functions, I think, already in the Python class.
Yes, sir.
For, yeah, yeah, these are like very specific things you can yeah. So another thing is, if you if you do any operation on an array, like on a numpy array, the values of the original array will get modified. But if you don't want that to happen, you can create a copy of that. So you can say d equal to a dot copy, and then like a copy of that array will be created, and you will avoid that. So then there is a concept of broadcasting in numpy arrays. So broadcasting is like numpy will automatically handle that. You don't have to worry about it. So you can like for example, when we were doing things like element wise product or matrix multiplication, so numpy has got vectorized these are np dot, so the dot function or the different functions, they're all vectorized functions and optimized, so it would take much less time if you use those functions. And okay, that's fine. Like these are just some things. Did you have you been taught matplotlib?
No, sir.
No, sir.
Okay, so matplotlib is the visualization library for like the most basic visualization library for Python. So you can see like we would typically do this. We would say import matplotlib.pyplot as PLT. Okay, so we would generate a distribution with mu equal to with the mean as 2 and the standard deviation as 0.5, and then you can say plt. So plt is an object which you got from matplotlib.pyplot, and then you will say so matplotlib has got different functions. So dot hist will plot the histogram of this v. So the total number of bins to use is 50, and you say density equal to true. And then you can also plot the you can also do a line plot. So you can say zero point 0.5 into bins 1 colon plus bins colon minus 1. So like all the uh, like 0 and 1th bin, so you sum them up and divide by 2 average of them, and then multiply them with the so not multiply, so this will be on the x-axis, and the whatever will be the your probability will be on the y-axis. So this will also plot a line. So you see this line is plotted. So this plt dot plot plots the line, the orange line. The plt dot hist, it plots the histogram for you.
Sir, what are those beans actually?
The bins are basically if you have data from, okay, if you have, let's say, np dot arrange, I say np dot arrange 100. Okay, so if you have 100 numbers, okay, so if your bins is equal to so if your bins is equal to 10, okay, so your data will get grouped in chunks of 10, okay, but it will be sorted. So like this one is, or this one is sorted for us. So 0 to 9 will go in the bin 1, 10 to 16 will go in the bin 2, and these numbers that you see, these are the frequencies or probabilities. So how many numbers are there in that particular bin? So if your bin size is 25 or bin size is 4, then you will have 25 numbers in each bin. So if you want to see what does a bin do, okay, so for example, if you let us see this np dot histogram, okay, and we say np dot arrange 100, okay, so then this gives you an n, okay, so these are the probabilities. So all the probabilities are equal. Why that is because in each bin, the number of numbers or the probability of each number is same. And these are our bins. So if we divide this into 50 bins, if you divide this into two bins, you see. So these are the probabilities in each bin, and these are the normalized probabilities. So in such a way that the integral or the sum of all the probabilities that comes to one. So then what are your bins? So your bins are, these are your end of the bin. So at 0, between 0 and 49, and 49.5 to 99. So the numbers lying between 0 and 49.5, and the numbers lying from, so that is the bin number 1. And then the numbers lying between 49.5 to 99, that's the bin number 2. Okay. Is
Yes, sir.
is that clear? Okay.
Sir, one more question that after plotting that histogram, there is one line. Okay.
Hmm.
So, do we need to hold those things like in MATLAB, or does the Python, or do Python does it automatically?
No, no. Can you come again?
Sir, first you plot that histogram, right? That or
Yeah,
the blue shade. Then after
yeah.
that, there is that line. Uh,
That line basically we use plt.plot, right?
So do we need to hold the first plot first?
No, no,
Uh,
nothing like that. I mean, whatever you do, it will just keep over. It will keep just plotting on the same plot. There are ways to do like make subplots and things, but until unless you specify something, it will just keep plotting over the same plot.
so
You
the
don't have to
so
do
Python
something.
so Python will not replace the first plot with the
No,
second.
no, no.
Okay.
So this was NumPy, and then we have Pandas. So Pandas we will take in the next class. Is what I'm thinking, because it will also take another 45 minutes. And uh, yeah, Pandas will take in the next class. So I will stop the recording here.